Good evening, everyone. I am Amog, a PhD scholar in Reva University, under guidance of Rohini Deshpande, presenting a review on behavioral biometric joint recognition. So, biometric actually means that using the physical characteristics, it can be like voice, can be iris, it can be thumb, or it can be walking styles. So based on the human characteristic, the one of a system is going to be designed. So based on that system, the recognition is going to happen or authentication is going to happen. So this authentication can provide authenticated access to the digital worlds. It can be access to the offices, or it can be institutions or non-governmental organizations or any kinds of buildings, corporate buildings. So here, joint recognition based on walking style, one of a biometric system is going to be determined. Based on this, the authentication is going to happen. So these are all my outline of the talk, starting from introduction, broad side of proposed system, available methods for joint recognition. So type of data acquisition. So what are all the different methods to acquire the data in order to perform a joint recognition. So few of a paper we have been referred with for data collection, pre-processing, segmentation, and classification. By having keywords of joint recognition, machine learning, deep learning, pre-processing, so segmentation and classifications. So introduction. So this image actually shows what is this? Based on the iris, based on the thumb, the authentication is going to happen. So biometric, we are knowing that it is a physical or behavioral human characteristics used to get an access to the digital world. So for digital systems, by using a behavioral or physical human characteristics. So physical is a category where iris, thumb, or what the physical sense is going to be used. Behavioral means signature, voice, walking style. So based on this, the access is going to be provided for the digital systems. So here we are having two modes in joint recognition, verification and identification. So verification is the one which is going to happen with one versus one. So identification is the one which is going to happen for one versus n. So it is having a two classification. So first one is physical and the second one is a behavioral. So first one, physical, actually we are being just discussed earlier. Physical means thumb, what is this, eyes or iris version, palm, full palm. So this is all physical. Behavioral means the what is this, walking style, signature, voice. So this is a trend which is going to happen in a biometrics, starting from fingerprint to multimodal. The most of biometrics is a this is a famous biometric is a face which is of having 40% trend compared to the other things. Next one is the multimodal combination of all the other models like fingerprint, iris, behavioral, wine. So this is called a multimodal. So fingerprint is the second highest biometric access which have been practiced by the people. Iris, behavioral is having a less than 3 to 4%. So this is we have been just looking for a behavioral version. So in that behavioral version, we are having a walking style recognition system. So continue of introduction, person authentication in public areas is one of the issue which is going to be faced with. So that is the reason why we are going for a video surveillance system. In that video surveillance system, the best authentication we can go with is joint. So why? Because the input devices, what is this? The input devices required to record the person behavior are invisible. So whenever the persons are having or seeing the input devices, they may become conscious. See, consider for a face recognition, they may close their face partially when they are moving towards the or passing through the input devices. Or it can be like closing their faces with the hands, clothes, or hairstyle changing, makeup. So these are some of the things or hurdles which are being faced in facial recognition. So here input devices are going to be lessly visible to the human beings. Why? Because we can just have a CCTV videos as well. So the next one is we can work on low resolution images. It can be tracked from a distance. So the coverage, we just need a low resolution image as well. We can just work on it. So on the walking style is not easily imitatable. So there will be some sorts of changes. So it can be tracked from a distance. So as per the paper one, 24 distant features are available to identify the human beings. So this is like a CCTV. We can just go for input devices. So broad side of a proposed system. So first method will be like first step will be acquisition, acquiring the database. So next one is to pre-process it. If you are having any noises, we need to remove it. So the next comes a feature extraction. Or dominant features need to be extracted, and it need to be stored in some of our databases. So feature selection. So as I told you earlier, we are having two modes. Verification means one versus one. Identification means one versus n. Like one test image will be compared with all the images or videos which have been present in a dataset. So classifier, we have been providing it to get whether the person is authenticated or not. So we can just see what are all the methods which are being available in a giant recognition classification. We are having broad classes like machine learning based and a distance based. So distance based means Euclidean distance, the distance between the foot, median distance, Mahaboolean distance. So foot distance, the length between the two alternate legs. So this can be like using a formulas and identify if the person is being same or not. Machine learning based, supervised and unsupervised. Supervised means we will be having both features and what is this labels. So the examples like support vector, decision tree, Navis pass. So it can be a deep learning as well. Unsupervised means it can be cluster based methods, K-means. So these are all the available methods to get a joint recognition. So here we are working with vision based and the two with the cameras marker free. So here joint acquisition technique are being divided into two sensor based and vision based. Sensor means variable sensor and floor sensor by keeping the sensor at the above the floor. So force plate, insole shoes, so wearable sensors. So the suit which is going to be weighed, or it can be a gyroscope, or it can be any kinds of accelerometers in order to check the position of the knees, or it can be the legs. Wearable means a full suit. Floor sensors, it can be a floor plates, or it can be one of the soles which are being provided inside the what is this shoes or slippers. Vision based, marker based, and marker free. Marker based means some of the tapes which have been included or attached to the human body in order to sense the positions or angles. So marker free camera and kinetic sensor. So camera is as usual CC camera, or it can be video recorder. Kinetic sensor is the one which is going to have convert your image into a silk house. Some of the papers we have been referred with appearance based. So compute the joint energy images. So this is called as an appearance based. So here the whole version of a human being have been converted into silk house. So compute the giant energy image. This is a giant energy image. Here hard with angles. We can the people are finding difficulty to handle with the different angles of working and with the different variety of cloths. So disturbance due to the shape changes. So if we are having any changes in the shapes like wearing bags or carrying a bags, or whenever a woman is having carrying or during a pregnancy. So next one is deep learning. So this is what the thing is giant energy image. So initially the images will be divided into three parts. First head, trunk and the legs. So based on this, we will be just dividing and we can extract the features. So the next one is deep learning based. So we are just we can just feed the pixels or video frames directly, and we can just have our one of our models, CNN models, to determine whether the person is belonging to the database person or he is an authenticated person. So behavioral based is one where the model is going to be designed like here. So this is what which is going to just see with. This is a one type of a sensor based one where the person have been attached with the various sensors or with the various body parts. So modeling of a human body motion by using some of a geometrical formulas. So various joints are recognized. So like this, the box is going to happen. So here, so for explanation's sake, we are having a preparation of a database for a joint, the three, and feature extraction and classification of around 7 papers. So this is a paper which have been referred in year 2019. So it is having some of features like it is having a database of 3 different databases. Database one of having 42 images, uniform background. See, like the images are being captured in a controlled environment. So camera is static and it is having some of a resolution here, 320 into 240. It is having 30 frames per second. And the same method have been applied for a second database. Two camera front facing with 20 and 70 feet apart. So these two cameras have been just placed. Outdoor is going to be happen. So here it is not a controlled one. 8 camera with 135-degree view and 60 view angle, means this is an object and the cameras are going to be placed around person. 8 cameras, 60 frames per second, walked indoor on a treadmill. So the subjects they have been taken care of, 6 human beings they have been undertaken for an experiment, 4 male and 2 female. In a data set 2, 34 males and rest of female. The data set 3, 9 males and rest are the females. So method what they have been just made with is a background subtraction in order to separate the background from an image in order to extract only the person. Feature extraction, seal codes, compute SSP, so self-similarity plot between the two persons. It is similar to the correlation. Find the frequency and phase of a joint. So classification, the template matching. So these are the features which have been stored in the database and they are going to compare it. Statistical pattern classification, the accuracy has been just taken for 6 people 100%, 54 people 70, 12 people 86% for a different data set. So the research gap is like less human beings have been employed with a uniform background. If noise is included, the accuracy goes down. Data 2 is of having FPS, frames per second of 20, which appears as an image instead of a video, and accuracy goes down in real-time scenarios as video is a continuous movement of images. Dataset 3, lesser number of people are considered. And the indoor database, walking on treadmill, so which is collection is going to be inefficient to the external changes if having any of external sun or any kinds of weather changes. So remark, template matching provides the lesser accuracy. We have been just suggested to have some of the more number of peoples in a database. So the second paper have been referred in year 2018. So they have been taken a database from a giant and activity SZ Taki. So subject is 24 different persons walked outdoor. Feature extraction is LDP texture. So it is just a dot version, local texture or depth information instead of a silk holes. So in the last paper, silk holes have been taken. Here local depth texture pattern have been recognized or taken as a feature. So by doing this, they have been achieved 74% for bend, watch, frown, and waving. So waving like this high, bending of a person, they have been just detected. Research gap is different types of LiDAR sensors and cameras can be employed. Thermal cameras as well to increase the accuracy. So thermal cameras may include the initial cost as well. So the next paper have been referred in year 2017 with they have been worked on Casio dataset. They have been extracted the giant energy image, Euclidean distance, And in order to reduce the feature values, they have been used a principal component analysis. Whole body has been divided into three parts: head, trunk, and leg position. So division is based on threshold values by performing the average of our silk holes. Classification is based on the minimum distance between the test and the database. They have been achieved with accuracy of 84. So different view angles is not considered by conducting the implementing the algorithm. Determining the dynamic cofactors for test images may provide a wrong results. So remark is like other machine learning algorithms can be just made with. So the next paper has been referred in the year 2019. They have been having some of the features. They have been worked on Intel Zen CPU and NVIDIA with a graphics card of GTX 90. So sensor position, center, left, right, and position. The database is OUISR. Feature extraction is inertia data as an input, and they have been designed 3 convolution layer with the average pooling, and they have been achieved with accuracy of 94. The accuracy is low for a center body with 85% compared to the left and right. Because sensor concentrate left and right, the motion will be more. So here, whenever the person is moving, the accelerometer and gyrometer readings may change if the person is ill. There is a remark. The next paper have been referred by in the year 2021. They have been achieved with accuracy of 70 and 82 by using two different classifiers, SVM and LSTM. So the input devices they have been used is camera, motion capture devices, and variable surface based devices here, which have been shown in the figure. So database have been they have been taken 18 healthy volunteer out of 18, 16 are male. So they have been just used embedding method for an SVM. LSTM direct 3D videos or videos have been just fed it, and the feature extraction is automatic. So variable devices data collected only in controlled environment. So whenever the scenario is going for a real time, then the accuracy may go down. Mapping between human skeleton and electrography need to be improved further. So the next paper which have been referred in the year 2000, the paper have been just published in the year 2020, and they have been achieved the accuracy starting from LSTM 78, so CNN 93 and a hybrid combination of LSTM and CNN 94. So device they have been used is Intel Xeon Gold 6126 with 8 cores and 2.6 GHz processor, 16 GB RAM memory. Dataset GAIT OUISR with 744 users on 118. Methodology is LSTM, so they have been used as stochastic gradient descent algorithm, dropout layers, and they have been having 15 bodies. So research gap is meant for determining the action for earlier frame and related to the current frame. So for identification, previous frame was not essential, which increased the time for training and testing. So next paper have been published in the year 2015. They have been just used a GPU on an NVIDIA CUDA with a 4-core of Intel i7 processor with a database of Cassia B methodologies like extracting the giant energy image. So they have been extracting and they are going to provide to the convolution network. So multi-layer perception means flowing of data from into a layers, multiple layers have been employed for classification. Class labels they have been taken as normal, code, walking with, back. These are the 3 different classes they have been just mentioned with, and they have been considered the angles 0 to 180, and they have been achieved with an average accuracy of 80%. And lesser number of humans have been considered 120. Hybrid models can enhance the accuracy. Next paper is being referred in 2020. Again, they have been having a data set of 36 adults allowed to work inside the door and with on the treadmill. So GPU computing with TensorFlow and KS have been used. So classifier is CNN, 99% they have been just made with. Overfitting to the training data may be possible, and the real time may just accuracy may go down. Smaller number of people have been taken. People are allowed to walk inside the controlled environment or at the treadmill. So on real time, the accuracy may reduce. Next paper is on 2019. They have been used Cassia OUISIR, the many input layers have been added in order to construct or determine the person. So accuracy is 91. So this is where the process is going to happen. So research gap is only Silco's images are applied or employed in an algorithm without having any videos. So obtaining a video and work on it. CNN is good for image, RNN can be works for video. So the next paper is on in year 2016. They have been worked on Casio dataset B and they have been achieved with the support vector ANN. So with the 82% and 89%. Proposed methodology is like noise elimination from silk code and segment the coordinates, estimate the missing body parts. So the features is Euclidean distance between head, neck, foot. So it can be angle and they have been used by AN. Once the model is trained, it is not tested for the real-time data. So again, the remark is outdoor and real-time validation is essential. So thank you for providing me an opportunity to provide a broader view on the papers we have been just observed with. So thank you.